Hi, I'm Steve Mushero, and I'm very happy to be talking today at Sensor Data's Tech Day. Today I'm going to be talking about observability, sort of what it is, why you need it, and sort of the hot trends and interesting things going on. So let's get started. The first question is, do you really know what's happening in your systems? You may think you know, but you probably don't. In other words, you probably think you have all your monitoring, all your systems set and everything, and you know what's going on all through your system. But the reality is you probably don't know that well. You can see some things, you can see the trees, you can see the first things like in this photo, but a lot of things are foggy and you really can't see what's happening behind the system or in the system and what's moving and happening in behind there. The reality is that today's systems are becoming more complex, harder to troubleshoot. This is a simple example where there's many moving parts, lots of different subsystems, microservices, and so on, and it's really hard to know what's happening. And then it's really hard to know what happens when something breaks or when it's broken and how to troubleshoot it. So we want to chat about this a bit. Most people have monitoring, and I'm sure you do too. And you maybe have Zabbix or Prometheus or Datadog or something of your own, and you're monitoring a whole bunch of stuff. A lot of people have logs, or at least they have some logs. Maybe you have Linux logs, MySQL, a few things. So you're getting some log information. You might even have APM or some sort of tracing where you can kind of see what's happening in your code and performance. But even with all of that, the reality is most people have no idea what's really going on inside a system, especially as it becomes more complicated. And this is especially true when something's wrong. Gee, why is it wrong? What's broken? It's really hard to know. And we have a lot of experience with this kind of problem. For example, we've had customers where everything is green, monitoring everything says it's fine. Everything is working normally, except the website is down or the app is broken and you don't know why. Every service seems to be right, but the whole thing is dead. So this is a real problem and it's becoming worse as things get more complicated, more microservices and that sort of stuff. And the real question is why? Why don't our monitoring and today's systems tell us what is wrong? And the answer is that traditional IT and operations tools, monitoring, logs, and so on, don't really do a good job of seeing what's happening. They can't observe or see what's happening inside the system. This picture just shows a lot of signs, a lot of information, a lot of characters. But what's important here? It's really hard to tell. There's just kind of a lot of junk. And you also have lots of information. I mean, we have lots of logs, lots of monitoring, lots of stuff, but it's all kind of a mess. I mean, it's really hard to see what's happening, and we're really not looking at the right type of data. Really, we tend to look at CPU and RAM and that kind of stuff, but that's not really what matters in the end. So this brings us to observability, which is a big word, but it really means observing or looking. But observing is more than looking. It's really seeing what's happening. And it's also about seeing new things and being able to ask questions. So it's not just to be able to see a graph of CPU or response time, but to be able to say, why are our users in Beijing on Apple phones having a problem if they're logged in? Or why is advertising not working in the South at noon? Or something like that. It's really asking questions that help you troubleshoot and understand your system. And this is really very important. Observability is really about that. So let's take a look at some history, looking back a bit at how we got here. First, there was monitoring, and we all have monitoring. And again, maybe that's Prometheus, Zabbix, Datadog, AWS CloudWatch, something like this. And we're monitoring a bunch of stuff. Most of this is pretty basic. It's about what's our CPU, what's our disk space, how much memory are we using, are things up or down, is MySQL running, stuff like that. Usually pretty simple, pretty easy to get, but not really that useful. These really aren't the important things to be monitoring. We'll talk more later about what we should be monitoring, but we get a lot of different data, and often we get conflicting data. We get data saying everything over here is okay, everything over there is broken, or maybe everything's broken, and it's really hard to know what it means. And very importantly, it tells us that we have a lot of alerts. And so this is a big problem for a lot of monitoring systems, is that we have a lot of alerts. And we've had cases where we've had thousands of alerts a day or even thousands an hour. And it's really hard to figure out what's important. Of course, you can have red ones and high priority ones, but that doesn't really help you that much. And then what happens is you have a lot of alerts every hour of the same thing. And so you get what's called alert fatigue. And alert fatigue is where users become fatigued or they become tired and they're sort of sick of looking at the same alert all the time. They always get some sort of performance alert or memory alert on this Java server, so they just ignore it. Well, then what happens later when it's a real alert or a real problem, they ignore it, especially at 2 in the morning. And then the system is down, the customers aren't happy, the boss wants to know why. So this is just really common in traditional monitoring systems. And the really important thing is that traditional monitoring and sort of all the things you're probably doing today are not focused on the end user. They're not focused on what the user actually sees. And the user doesn't see the CPU. They don't see the disk speed. They don't care about the network. They don't know about MySQL. They want to buy things. They want to watch video. They want to pay for something. They want to give you money. And when that doesn't work, or it's very slow, or they get a 500 error, that is a problem. And maybe it only affects a few of them, but maybe they're VIP customers. And so we really need to start focusing on that. I'll talk more how to do that. It's actually pretty difficult, but it's something we need to think about. Also, on top of monitoring, people have logging, and you probably have some of this. You're taking some text out of your services, your Linux kernel, various things. You're feeding them to Elk servers and so on, and you have some basic logging. And usually it looks something like this. There's either Java exceptions like this, which are lots of unstructured text, or there's some print or write line that writes out, started this function, start that process, this errored. And it is really, really difficult to search this and use the data, right? If you have gigabytes of logs and your site is down, it's really hard to figure out what's wrong. And it's really hard to figure out where should I look, which developer, which system it is. So today's logging is actually usually pretty bad. And that's a big problem as we try to improve our systems. We also have APM. And so that's application performance management or monitoring. And that's pretty useful. It's mostly for developers, and it's mostly to work on sort of performance and, where's my code running slowly? What SQL is slow? Stuff like this. And it can maybe tell us, that one runner on the left is going faster, the other things are stuck, blocked, whatever. And that's really helpful in some ways, but often doesn't really tell us why our system's broken or why it's really slow and things like that. So it's helpful, but not great, especially to operations. And the reality is that systems have evolved over the years. We started very simple, maybe LAMP stacks, a couple different servers, and they've evolved over the years to be sort of more sophisticated, bigger, more complex. So you sort of see it going up the chain there. And they really end up with today's modern systems, which are, cloud oriented. We have cloud services like RDS or SMS or SES and so on, microservices everywhere for authentication and payment and searching and lots of things. Of course, Docker's involved for a lot of people. We have APIs, both inside and outside, mobile and all that. So you get systems that look like this, that are, pretty messy and lots of parts. Here's just a quick example. On the left side, we have a traditional LAMP stack, Linux, Apache, MySQL, PHP, kind of a couple layers, very easy. But on the right side, you have kind of what people are building today, which is filled with sort of, cloud services, microservices, Kubernetes stuff, application services, PaaS stuff, payments. And if any one of these boxes or little circles is broken, your system is broken. And then when it is broken, how do you figure out what's wrong? And that's a really serious problem and getting worse for companies that use more and more of these things. So we need to start thinking about that. Also, the questions have evolved from, hey, how's the system doing? Why is it broken? How's the CPU or something? To where is the data and where is the code running? And who does this application or this server or this service talk to? Because it changes all the time, right? Microservices and DevOps, things change a lot. This application code used to talk to that application code. Now it calls this, and then it calls Redis, and it calls Elasticsearch. So knowing who's talking to who and where is really important. Back to this diagram, this is not very complicated, but there's quite a few pieces here, and there's a lot of dependencies. So if any one of these boxes is broken, you're likely to have a problem. And maybe not for all of your customers or all of your users, but for some of them, and you're probably never going to know about it. And these are the problems we're trying to solve. Is how do we troubleshoot this system? How do we optimize performance and so on? Where do we spend resources? Do I need more servers, more memory, that kind of thing? So this is what observability helps us with, which brings us to our big question. What is observability? And really, first, it's about seeing the internal state and operation of the system. So it's really how the data, how the API calls, and how the functions and code and so on within a system are flowing and connected. So here you can see lots of pretty colored pipes, but in a system, all those pipes are carrying data, API calls, and so on. And we really want to know how they're all doing, which ones are going where. Some are for security, some are for database lookups, some are web calls, some are payments, various things. We want to see all about all of that. And that's a lot of moving parts, right? We also want to see what is where, because that changes a lot. As you have, again, a lot of DevOps, things moving, new services, what was over here yesterday is now over there. And now we're talking to this. Maybe we're doing A/B testing and lots of other things. And so, what is where and who's talking to who is really important, because if I'm talking to you, I depend on you. And if you break, that breaks me. And so we need to know about that. And that's not very easy, actually. Also, we want to know who's slow and who's broken and how we can improve performance. Maybe we have a lot of talented people like you see here, but they need to know what to work on. They need to know what to focus on. It's very easy to focus on the wrong things. Everybody wants to fix SQL queries, but then they find out that isn't really the problem, or authentication or something else, right? So observability helps us find the things we really should be focused on and thinking about, particularly if it's just slow or broken sometimes, because those things are really hard to find. Observability also helps us think about and understand complicated architectures. Again, you may have lots of services, lots of microservices, hybrid stuff, talking between the cloud and the data center, and lots of different pieces and parts that are sort of moving around. So observability again helps us think about, how does that work and who talks to who and so on. So that's very helpful. And it's all very important. The real question is, again, why is observability important? Why can't I just use monitoring? Because we really want to know what's going on. And certainly Silicon Valley and lots of places, this is becoming much more important. And part of it's just about asking questions. It's not just looking at graphs and going, oh, the system's down. Now what? Why is that CPU high or that disk low? But it's about finding the things we don't know, especially in complicated systems. Why is the advertising system not working on Android in the north? Or why does this server always have 500 errors, at 2 in the morning, but those don't? These are things we really need to find out if we want to provide high quality services, to our customers. And it's also about finding outliers. Most of the systems that most of you probably run are getting large. So we have lots of servers, lots of services, lots of pools of servers, and we need to know what's weird. Normally, hopefully, things run pretty well, but then there's weird stuff. Again, some location, some browser, some type of user, some type of product, one of the payment processes, doesn't work. So we have this white egg on top. Maybe our WeChat payments in one place just aren't working if it's over, 10,000 kwai or something. And so we really need to see that and start to work on that. We can't just look at the averages and say, well, on average, everything's working. On average, our customers are getting web pages. On average, the system is fast. Today in modern systems, that's not enough. We need to find these outliers and deal with them. We'll talk more about that. And particularly remember that most systems today have high availability. They have load balancers, so they tend to have pools of systems. So in this case, there's just 4 servers on the right. But what happens when one of those servers has a problem? That's only 25% maybe of your system. So 75% of the users have no problem and don't report anything, but maybe 25% do. And maybe that server only has problems sometimes on some customers, on some phones. So now you only have 5 or 10% problems. And this stuff is really hard to find because it's not an outage, right? If your MySQL system or Oracle is down, it's pretty obvious because the whole system's dead. But it's these smaller problems that really bother customers and users and affect your company that are really hard to find. So we can try to find that. We also are looking for correlation and context. And again, when and where does this happen? Which pieces, specifically what users, what products, what services, who does it affect? Is it only one type of payment? Life is complicated. A lot of us maybe log in 4 or 5 different ways. We have 2 or 3 different types of phones. We have 5 different browsers, lots of geography, lots of countries. Maybe we have several payment systems, WeChat, Alipay, lots of others, and maybe only some of those don't work or have some problem. We need to understand the context of that. So this is where observability really gives you a lot more data and a lot more information than just, say, Prometheus monitoring. So it's very important to think about that. Observability also tells us, what's important because we build new systems all the time, we change them all the time. Where are the problems? Maybe MySQL works great. We think that's a problem, but it works great all the time. But it's this weird little WeChat gateway that we use for every customer that gives us a lot of problems, or at least a lot of problems for VIP customers. And so things like observability can really help us find that and pay attention to it and say, hey, we need to add more resources here. Or this service really has a lot of problems, or maybe we have code issues and so on. But it lets you find, what works really well and maybe what doesn't work really well and where we have to focus, more monitoring, more observability, better logging. It's very common. The developers need to spend more time on this, things like that, right? In big complicated systems, this is really hard because you've got 1,000 parts and you don't know which 10 are really important or which one. So observability tries to help you think about that, especially when things are broken. It's one thing if things are slow, but when things are really broken, finding out what's where and finding out what's important are really important things. And this is also true when things are partly broken. Because again, reality is your systems probably are not totally broken or totally down very often, at least I hope. But they probably have small problems a lot more than you think. Even in Silicon Valley, people are finding, sometimes 1, 5, 10% of their users have problems all the time, and they just didn't know. And maybe the users don't tell you; they just go away, and that hurts your company, hurts your money, revenue, all of that. So, finding out what's broken or seems random, or for some users, even when it seems to work, is really important. So, how do you build this, and what do you make of observability? How do you get there? It's pretty straightforward. And so, one thing that's important is observability is mostly for operations and sort of DevOps, but also developers. It's really a team of two sides, right? So you need developers to do things, you need to add logs and events and things in the code we'll talk about. But you also need operations, of course, to do a lot with infrastructure and things like this. So there's two parts of this to sort of build observability. And there's also two parts to sort of kind of using it. Again, mostly operations to help fix and find things, but also developers to dig into troubleshooting because, operations, developers, and DevOps sort of all together is a partnership. And it's really understanding what's going on. Not only what is the infrastructure doing, but what is my code doing? What's the application doing? What are our partners doing? What are the third parties doing? And how do we solve problems there? Because it's not pointing fingers at anybody. It's trying to solve, real issues, right? So how do we do this? First part's pretty standard. It's sort of metrics and fairly much traditional monitoring, but with some differences. So, of course, we want to monitor resources, CPU, disk, and so on. It's still important, and we still need to monitor that. That's useful to tell us when we run out of things, right? Because if it's 100% CPU everywhere, we want to know that, especially if it's correlated with other things. We also want to monitor our services, which probably most of you are doing. And all of our services usually have standard, metrics and things they can give us. And usually most of the monitoring systems, can do that. So whether you have Apache or Redis or Kafka, whatever, you can get standard data from that. And that's just really helpful when things go wrong. It's not your primary thing you're interested in, and you're not going to alert on most of this, but it's what you want to be monitoring. And there's many ways to do this, right? Again, Prometheus, Zabbix, a lot of people use, maybe CloudWatch, Datadog, Grafana, Elasticsearch are kind of new. You want some dashboards, basic stuff, right? These are here as tools to help you troubleshoot. And there's also advanced stuff. If you're a big MySQL user, you can get more advanced data for every query, every issue, and so on. But that's only if MySQL is a problem. But you can dive into any particular service if you find that that's really where your problem is. And this is from Vivid Cortex, which is an advanced MySQL monitor. So lots of stuff. But most importantly is you want to think about metrics for your end user. And this is actually really hard to do. We'll talk about this. But you want to think about what are they seeing. Again, they don't care about your CPU. You care, but they really don't care. They want to know, is my website fast? Can I pay? Can I buy? Can I watch? Can I do what I want? So you have to really think about how can I monitor what they're doing and what they're seeing across the whole country, across different phones, across different things. This is really, really important. And if that's only one thing you get from this, it's thinking about end user life and metrics and data. Very important. And we really want to talk about SLIs, service level indicators. And this is for every resource, every service, and especially for the user. Again, CPU and so on is helpful, but you really want to get these things if you can. And this comes from sort of the Google SRE book, and they call them golden signals. Also today they're called SLIs. And these are really the things you want to get, and it's difficult. But you want to, if you can, get latency, which is how long it takes to do something. This is the web request. This is every API call, usually every SQL query. So that anything that happens in the system, especially when one system calls another system, you want to know how long it takes, because this is the easy indicator to know how you're doing and how you're performing. It's very important, and again, hard to get. Rate is how often you do something, requests per second, queries per second, things like that. That tells you roughly how much load you have and kind of what's going on. If it's really high, you usually have a lot of load. If it's low or zero, something's broken, right? So it gives you an idea of generally what's going on. And latency will tend to go up as the rate goes up. If they don't, something's wrong. Errors, this is obvious, but you want to track your error rate, and I bet most people don't know. Today, your website is serving how many 500 errors per second? You probably have no idea. But it's really important because your users have an idea because they see them. And so you really want to look at the errors, but again, not of just your public-facing services, but everything internally. If you call WeChat to make a payment and you get an error, you want to record that. And you want to maybe retry, but you want to know it's happening, because errors obviously and higher error rates obviously show where something's wrong. And you can look at the system and say, this is an error, that's an error, that's an error. You want to find the root error down at the bottom. Oh, that's some database error. Okay, we can fix that. And that's one of the ways you troubleshoot, because your error rates will change quickly. And you also want to look at saturation if you can. This is the concept of how full your system is. CPU is an example of this, but often you use queues. So run queues or database queues, or certainly disk queues. So if your disks have a queue and I/O is backing up, this is going to be a problem, and it's going to slow you down, and then your latency will go up. So anyway, these are things you want to track through the whole system. Reality is these are hard to get, and actually we've written some papers, and I've written some papers on how to get this stuff from logs and places, because it's not easy. But things like HA Proxy, Amazon CloudWatch, and so on can give you direct metrics, so much latency and so on. Nginx and Apache, which everyone uses, do not have this data. So you have to get it from the logs, and that's not so easy. So you have to actually extract error rates from logs, but it's very important to try to do this at every layer. APM can also help this, so it's interesting. Also, you want to build logs and events. Logs and events are the same thing, but you want more of them. So, of course, you want to start with the basic logs. These are easy. Again, from Tomcat and Apache and Linux and so on. You want to pick up the basic logs and use a machine like this, or an agent like FileB, to just go and grab those logs, right, and pull them into Elasticsearch. That's pretty easy. But you also want application logs, and you want good application logs. So this is where the developers come in, and where you want to actually be writing code to put out events. And usually you want to try to track, start and stop and when things happen and all that. But you need to put out good quality events and logs that then you pick up with, a log shipper or something like FileB or something, and you pull into Elasticsearch so you can see them. And you really want to focus on the health of things and the timing. Don't just put out random messages. Put out, starting this, starting payment, payment results, payment timing, and so on. So think about, again, what's happening, what's the rate, what's the latency, what are the errors for everything that you do. So if you do all that and put out good logs, it's very easy to trace through the system and see what's going on. So of course we can get that from Apache, but then when Apache says there's errors, then what? Then we have to dive deeper into the application and see what's going on and see, oh, look, an Alipay payment gateway number 3 is causing a problem. Okay, we can work on that, right? Structure your log in events, right? Don't put out text if you can help it. Don't put out just write lines and basic data. It's very hard to parse that. So use JSON if you can, and put out fields. From that we can get real data. We can search it, we can extract metrics, we can say, oh, how often, if we know that the user has an Apple phone and a Safari browser, we can pull out that data from your logs and we can see what's going on. So give us good logs and we can look at that. If you can, put IDs everywhere, especially a request ID. Tracing will do some of this, but if you can put IDs in, we can start to connect things together. We can see end to end in a distributed way. So that's why we see the birds here. So at each step of the way, if we can get good IDs, we can trace things all the way through. So it's hard to do that perfectly, but the more you can do, the more help you have, especially for troubleshooting and looking at data and logs and stuff. Also, you want to include context. Give us fields or tags for things like who's the customer, what type of customer, what type of browser they're using, what IP they're using, the server, and so on. The environment they're in. The more information we have, generally, the better we can, again, look at details because it only fails for one type of customer, one type of place on one type of phone. Well, we need to know that. If we just say, oh, payment failed, it really doesn't help us figure out what's going on. So that's important. Also, for those of you running large volume sites, which is probably a lot of you, use sampling. And there's lots of papers on this, places like Honeycomb and so on, that tell how to sample and how you can look at your data, if you have a lot of it. Usually you don't have to keep it for very long. Logs and events like this, more than, a week, not that helpful. You can distill them down and sample, but you want to know what's going on and you want to have a lot. Also, if we get good metrics or good logs, we can get good metrics. Again, from Apache logs, Nginx, we can extract, good errors, good rates, good latency information like that from the logs. We can't always monitor them because Apache doesn't give us, latency metric. So it gives us a log we have to create a metric from. And Elasticsearch and things can do this. And it's worth your time to do this. And then we know, why is this Apache server slower than that one? And we have to go research that, right? So that is very important. We also want to combine metrics and log. This is really hard. Most regular systems don't do this. Commercial systems like Datadog can do this, Elasticsearch can do this, but Prometheus and others really don't. But if you can, try to combine your metrics and logs together so you have the timing, right? We got this alert, this latency got higher, let's go see this log. This error rate started to happen. Now we can go look in and see these errors are going on and why. And it's pretty easy to figure that out. But if you tie them all together on the same time, we can see more easily, right? And the third part is really sort of APM, distributed tracing. This is fairly popular, particularly outside of China, and pretty useful also to know what's going on. There's various global companies that do this, also Tingyuan and some others here in China. There's some open source parts like Jaeger and Open Tracing. These are usually agents or libraries that you put in your code, so it's important for the developers. But they provide a lot of useful information, basic performance data, classic profiling, so you can see how fast things run. But more importantly, you can see dependencies. So you can see here, a little complicated, but you see who calls who and how fast. And the APM tool can actually give you a lot of those latency, a lot of those error, and a lot of other metrics without you having to do anything. So it's pretty nice to be able to see a lot of information without having to do a lot of your own work. So different systems are different in how much you need to use that. You also can look at tracing across systems. So this request came to serve web server 1, went to app server 3, went over to microservice, payment server 27, and then called WeChat. And we can trace those things through that whole process, and that's pretty useful. And then some hot trends and other best practices as you're doing all this. One is enrich the data with tags. Again, this is including everything you can about the customer, the type of customer, the environment, which server's involved is very important because usually server has a problem. Development versus production environments, all that type of stuff. And all the details you can include this to Prometheus display where you see different tags they've sent us. But it's very important that you be consistent. Don't randomly change things. Make sure your developers have the same tag and the same meaning all the time. If you change in the middle or it's kind of random, the data is useless. So make sure you have consistent definitions and words in things. Have a standards document for this. Being careful of cardinality. Some systems like Prometheus and some others need to be very careful what you use in the tags because they'll sort of blow up if you have too many IPs or sessions or data that can have a lot of value. So you have to sort of limit that. And you can read about that. But that's an important thing is how you manage your cardinality if you have a lot of data. Again, always focus on user impact. That's just really important all the way through. Think about the user all the time and then work backwards and how do my services support the user? Look at user-facing metrics, then internal metrics, all the way back to your sort of databases, disks, and other things. But really think about the front. And it's hard, but that's just a really important part. Think about percentiles. This is really common these days, especially looking at latency. In this case, it's saying 90% of our users get a response in less than 3 seconds, but it means 10% are more. And most people are using 99%, 95%, 99.9%. You want to use a very high number. And that's how you make sure your system is serving all your customers well. And that's really very important. Don't change things all the time. Make sure you treat this like code. Make sure you have change control. Don't change metrics every day because then you can't use them. So think about how you add and do stuff. Also, if you're doing hybrid systems, service metrics, and these things are all more important because you've got data centers, public clouds, private clouds, all connected together, and things go wrong, networking problems, other problems, and you need this stuff even more importantly when you have lots of different systems. Maybe you have enterprise systems, corporate systems, all tied together. And so you need all of this to really see where things are. In a quick summary, observability is just critical to modern systems. In Silicon Valley and places like that, you see these everywhere. You see a lot of tools, a lot of things helping you do this. And a lot of it's just basic, adding monitoring, adding metrics, adding events, looking at all the right stuff from a user perspective. You can get there in phases, so you don't have to do everything today. So it's important to just start, right? And then you can sort of go up one step at a time. Add this, add that, add this, add that, and keep getting better and better and better as you go. And it's usually pretty easy, and you can just take a lot of steps to get there. And that's really it. Start now. Keep observing. Do all you can to get as much data and information out of your systems as you can. Keep looking, and it will get better and better. And that's all I have. Thank you very much.